Welcome to Buddha at the Gas Pump. Buddha at the Gas Pump is an ongoing series of interviews with spiritually awakening people. My name is Rick Archer. We've done nearly 700 of these now. If this is new to you and you'd like to check out previous ones, go to batgap.com, BATGAP, and look under the past interviews menu. This program is made possible through the support of appreciative listeners and viewers. So if you appreciate it and would like to help support it, there are PayPal buttons on every page of the site and a page offering alternatives to PayPal. Also, we have a team of volunteers doing a number of different things, proofreading transcripts of the interviews. Lately, people have been picking out shorts, which is like a little 60-second clips of. So as you're listening to this interview or any other of the interviews, if you hear something that really, piques your interest and you think it would make a good short, note down the timing of it. When it starts, when it ends, it has to be less than 60 seconds, and let me know, and we'll make a short out of it. Also, some people are making chapters, which is a thing that is very useful. I won't go into explaining it now, but if you'd like to volunteer in any of these respects, get in touch. My guest today is Ruth E. Kastner. Ruth is a physicist. She earned her MS in physics and PhD in history and philosophy of science from the University of Maryland. Since that time, she has taught widely and conducted research in foundations of physics, particularly in interpretations of quantum theory. She was one of 3 winners of the 2001 Alumni Research Award at the University of Maryland, College Park, and she's the author of 3 books: The Transactional Interpretation of Quantum Theory, The Reality of Possibility, Understanding Our Unseen Reality, Solving Quantum Riddles, and Adventures in Quantum Land, Exploring Our Unseen Reality. She has presented talks and interviews throughout the world and in video recordings on the interpretational challenges of quantum theory, and has a blog at transactionalinterpretation.org, which I'll link to from her Batgap page. She's also a dedicated yoga practitioner and received her 200-hour Yoga Alliance instructor certification in February 2020. So welcome, Ruth.
Thank you. It's a pleasure to be here.
Yeah, it's good to have you. Now, you are actually typify what the reason I wanted to do this interview with you, which is that a lot of people are interested in both spirituality and physics. Now, unlike most of them, you really understand physics, and your books were very interesting. But a lot of the material was way over my head. I have no training in physics, but I'm well aware, and I've done it myself and still do it, that spiritual people who are interested in spirituality often make reference to quantum mechanics or some other principle in physics to illustrate and hopefully substantiate some spiritual concept. So I have a whole list of such spiritual concepts that I want to talk about with you. But before we get into that, let's just talk about you a little bit more. Have you been practicing yoga a long time and been interested in such things for a long time?
Actually, I've always been interested in, I actually was into gymnastics early in my life. So I very much, physical fitness is important to me, and being kind of comfortable with my body, feeling like a unified being, both body and mind, has always been really important to me. I actually, when I did the yoga training, it was kind of from a position of ignorance. So I'm kind of later in life. I thought, I think this is just something I want to do. I was doing a little yoga, and I had taken some yoga classes. So I wasn't a complete beginner, but I wasn't really, the advanced level that you usually think of, a yoga teacher. But I thought, it was a very welcoming course. It was offered. I was actually living in upstate New York near Saratoga Springs at the time. And there was a studio that was very welcoming, and they offered a teacher training course that didn't have formal prerequisites. And they just let you know, look, this is going to be fairly demanding. If you want to broaden your yoga understanding, whatever, we suggest you, if you're not really a seasoned yoga practitioner, get into it. And it was very challenging for me, and I really enjoyed it and learned a lot. And I had got a little bit of a shoulder injury from overdoing it. So in a sense, I wasn't quite, didn't quite have the prerequisites, but for me, it was a crash course and really fascinating fun. I learned a lot about the yoga philosophy, the yoga Patanjali sutras and so on. So it was a very good, well-rounded course and just kind of fit into my general interests that way.
Good. Well, I was going to ask you actually if you had, gotten into the philosophical dimensions of it and read Patanjali and all. So you just answered that.
And I should say, actually, I was a long-time TM practitioner. I'm at TM City, although I'm fairly lapsed in that regard. So that's one reason I was also interested in yoga and had been exposed to the Yoga Sutras through that program.
Okay. Yeah, I was a TM teacher. In fact, I used to teach all over New York State back in 72, 73.
Interesting. I said it wrong. A Siddha. I'm not a Siddhi. I'm a Siddha.
Yeah, I know what you mean.
Lapsed Siddha.
Right. Me too. Okay. So why don't you, keeping in mind the general, educational level of our audience with regard to physics, which is probably something like mine, pretty meager. Why don't you an overview of what your work has been all about and how you feel it dovetails with spirituality, if you feel it does.
Okay,
and,
well,
go on for a little while, and then I'll have all kinds of questions.
Okay, sure. Well, I actually got into physics through a very, not through not a spiritual angle at all. My family was very agnostic, and you might even say physicalist, materialist scientists. So my father was a solar physicist. But what I got from him was a fascination with light. And he very kindly would expose his kids to things like he'd bring out a spectroscope home. This is a little device that kind of breaks it. It has a prism in it. It breaks up the light into the colors of the rainbow. And of course, that just grabbed me. And I thought that was magical. So that was kind of my motivation, in a sense, for getting into physics. I did some other things. I did art and music, but I came back to physics sort of, I guess it's a family thing. But that was my motivation. I just thought light was fascinating. It grabbed me. And I wanted to learn about electromagnetism, which is the field that underlies light. So in the course of doing my physics degree, I came across these quantum paradox, the non-locality, and these kinds of issues. And then that sort of grabbed me. And by the time I finished up my master's, I really wanted to learn more about that. And I discovered that in the philosophy department was where they had this program called the Committee on the History and Philosophy of Science. And in that group, they were really studying what's called foundations of physics. So they were really focusing in on kind of what are the philosophical implications of quantum theory and these strange phenomena, whereas the physics department was much more kind of, we want to do predictions, we want to test theories, and they weren't so much interested in the philosophical implications. So that's why I ended up in that area. And it was in doing my PhD in that program that I came across the transactional interpretation that was originally proposed by John Kramer. And that grabbed me because I think that it dealt with this idea of, it had this sort of intriguing backward in time character that seems very counterintuitive and yet seems to be very effective in deriving certain things like the rule for the probability of outcomes. So, in quantum theory, basically you have, it's called the Born rule. It's named after Max Born, who was one of the founders of quantum theory. And it tells you, well, what is the probability that if you do a measurement of something you want to observe, it's called an observable, like momentum or spin or something like that. What is the probability that I'm going to get any particular result? So this rule is kind of ad hoc in the usual theory. It's a thing that works. but it's sort of people are not really sure where it came from. Why do we have this rule and so on? And the transactional interpretation had the advantage of explaining that rule in a theoretically kind of substantive way. So even though it had what seems like, and I'm going to say what seems like backward in time effects, I thought, okay, well, look, if this is what it takes to make this theory make more sense and not be so ad hoc, maybe nature's trying to tell us something. That was kind of my feeling. So that's why I started to explore this transactional picture. So with that as a kind of a place to start, maybe you have other questions or
okay. And also the audience, we have about 100 people on now. There'll probably be more. Can feel free to send in questions too about any of this. So, you mentioned you were in the TM movement. Are you aware of John Hagelin?
Oh, yes. We've met. And he participated in a conference in Los Angeles at, what is the name of the college? Where the names I'm blanking on the names now, but a group of physicists at, I can get the name of the college.
Down in the San Diego area, Manaus Capital?
No, it was LA, Chapman College.
Chapman, okay, that's where Manaus
Manaus, yes. Right. He's a lovely guy. And he thank you. He organized a conference and John Hagelin was there and I was there. We a number of us presented some things. And I think your original question was, what is the connection with spirituality? Right. Possibly. If you want, I can kind of try to.
Well, yeah, I was going to ask. First of all, I was John Hagelin's TM teacher when he was in high school and lying in a body cast in the school infirmary. But that's a whole other story.
Oh my goodness!
But he wrote an article years ago called "Is Consciousness the Unified Field?" And he argued that he felt that there was an equivalence between the unified field as physics attempts to understand it and consciousness as it's been traditionally understood in Eastern spirituality. So you could use that as a springboard if you want, and continue on. Yeah.
Well, yeah. I mean, the issue of consciousness, ultimately, on a very ultimate level, one could certainly propose that. And I think it would be consistent with physical theory, so-called physical theory, quantum theory and so on. And I think, and the connection, I think, with I'm going to call it TI, transactional interpretation, just for short, as I've been developing it, is that properly understood, TI really, and actually standard quantum theory in a sense, really implies, if we want to take a realist approach to the theory, in other words, if we want to say, well, this theory is describing the world. Okay, the quantum theory itself has this very strange mathematical structure. This abstract, complex, it's called Hilbert space. And it's clearly not a space-time kind of structure. So if we want to be realist about that, meaning if we want to say this theory is referring to something in the world, then that to which it refers is not 3 + 1 real valued space-time. That's just kind of a straightforward inference. So what we have then is, is a picture in which quantum theory is kind of saying to us, like a finger pointing at the moon. It's like saying, okay, maybe you can't, here's what I'm pointing to. You can either say I'm just, theory talking. The theory's talking now. You can either say I'm just an instrument for predicting what you're going to experience, or you could say that I'm reflecting the structure of reality. And if I'm doing that, then it's got a very strange sort of abstract structure that I view as kind of possibilities, kind of potent possibilities that truly exist at a level that goes beyond the space-time, phenomenal level. So that you can kind of see an opening for spiritual pursuits in that, people who are doing spiritual inquiry are entertaining concepts and experiences that clearly transcend our usual concrete, mundane space-time world. So there's a parallel there.
Yeah. Right. And so, in let's say the Vedanta tradition, to which, the idea is that consciousness is fundamental, and that some would say the world arises from it. Vedanta would actually be a bit more radical and say the world doesn't arise; it just appears to arise. They use the analogy of, perceiving a rope on the ground and thinking it's a snake, and then you eventually realize it was only a rope. So where did the snake go? It didn't go anywhere. There never was a snake. So the understanding is that the universe is sort of a fabrication, which is ultimately illusory, and that it's actually all consciousness. This microphone, our bodies, everything else is just consciousness through some kind of perhaps self-interacting mechanism appearing as concrete stuff. And, symmetry breaking to the point where we have all this huge diversity out of total unity.
Right. And that is exactly the picture that you get in the transactional formulation. So another, and I'll elaborate on that in a minute, but another issue that I'm dealing with is that the standard formulation of quantum theory actually is flawed in that it does not have this transactional character, and that there's kind of a long story that goes with that gets into some technical issues. But it if you want to kind of put it in terms of yin and yang, just to kind of get an overview of what's the deal here. Standard quantum theory inherits this yang picture of this sort of Western autonomous yang thing, where yang is like the initiating, creating process, whereas yin is a receiving, responding kind of process. And the Western metaphysical approach does not know about yin, does not see yin. It sees only yang. So its theories are yang theories. And in the yang theory of field, the formal quantum fields, you can never get this, what you just called symmetry breaking, crystallization, manifestation at the phenomenal level, which I would say is not illusory. It's just simply a different form of being. But it's so, anyway, I'm kind of going off in a number of different directions here, but in the short answer there would be, there was a rope, something happened to transform that rope into a snake, perhaps at a phenomenal level, but it could also morph back, transform back into a rope. So you have this sort of dance of quantum possibilities that really do manifest, create space-time events, create a phenomenon that's really there. In a sense, it has a physical counterpart. So it's not wholly subjective, but it's not the whole story. And it's not as concrete as we think.
Right. And we always hear that, that which appears to be concrete is really 99.9999% empty space. So is there anything? In fact, I heard about some physicist who got a little bit mentally unbalanced, and he was afraid to walk across his living room floor because he was afraid he might fall through, because he realized how empty everything actually is.
Yes. I might be having an internet issue here. Just there might be a bit of lag, but yes, I mean it's sort of if you start thinking of the quantum possibilities, then you kind of, the concreteness seems to vanish, and yet paradoxically, and I make this point in my book, Our Understanding Our Unseen Reality. Paradoxically, possibility is the strongest thing in the world because it's what keeps atoms stable. If we didn't have quantum possibility, everything would just collapse in on itself. There'd be no structure at all. So it's an ironic thing. And in an atom, the more you try to compress the electron so-called cloud, because this is the non-locality, this is the indeterminacy. The more you try to localize it, the harder it's going to push back on you. So the physicists needn't have been worried. The possibilities will support you.
Interesting. Let me understand a little bit better what you mean by possibility. I've often heard the idea of consciousness being an infinite, unbounded field, which is a field of all possibilities, a kind of like an ocean of anything goes, all possibilities, and that as it manifests, the possibilities diminish the more concrete or manifest the creation becomes. And eventually become very sort of isolated and localized. I mean, anything can happen in the field of consciousness, but a rock can only do so much.
Right, kind of right. Yeah, and this, I mean, and one part of this issue then is that quantum theory, I would say, really can only address perhaps a subset of what we would consider this field of all possibilities. So quantum theory is not, is not addressing my particular thoughts running through my head at any given time, like what should I have for dinner or something. As far as I know, there's nothing that quantum theory can tell us about that. So it's a more of a restricted, I mean, what we would say is that Hilbert space, which is the structure of the quantum possibilities, refers to a subset of, all possible processes. It just refers to specific things like the elementary particles with which we're familiar in physics. So, I think it would be kind of overstating physical theory. It would be overstating the parallel to say, well, physical theory refers to the field of consciousness and so on, because we don't really know that. I mean, it might, but there are very specific quantum fields. There are, the fields that correspond to the electron, and so on. And so an electron isn't, my thought of a purple rhinoceros, so there are many more kind of conceptual possibilities in that totality than quantum theory can really address.
Okay. A couple of questions came in from Elizabeth in Colorado. Let me just hit you with those and then we'll continue on. So she's asking regarding using quantum theory not only to predict experimental results, but also to describe reality. What is your definition of reality?
Well, insofar as physical theory is concerned, what I feel I've learned from studying quantum theory is that reality is, again, I use this image of an iceberg, there's a lot of it that's submerged, and then there's just the little tip sticking out. So in terms of physical theory, I think of it that way, that the whole iceberg is real, ontologically, meaning the term means what exists, what really exists. I think that the tip of that iceberg represents that space-time phenomenal concrete realm of mundane reality. And the submerged portion represents these quantum possibilities. And those are completely real. They're just as real as, if not more so than the phenomenal level. So that's kind of in physical terms. Yeah.
Sometimes when I hear people say, well, the world is an illusion, the way I come to terms with that is that it doesn't mean that there's nothing there. It just means that we really don't interpret it properly, or we only, like your iceberg analogy, we're only sort of seeing the tip of it, and there's so much more reality to it that we don't comprehend or apprehend.
Yeah, and here I think the online role-playing games, the MMORPGs, and I know about these because my daughters are both gamers. That's a wonderful analogy because and the analogy goes like this. So, the users are sitting in their houses with their, computers, and they've got their computer screen, and that's their point of view, their POV. And they have an avatar that runs around in some environment in the game, right? But they are not their avatar. They're playing this game. Now, the game POV is analogous to space-time. Okay, so it's important in that, if your avatar's running around in some zone and you fall off a cliff, your avatar is going to incur damage. And if you have some goal you want to achieve, you're going to be held back in your goal, or so on. So it's kind of a user interface that allows you to get around and do stuff, but you don't really live there. You're, I think of the space-time realm as the same way. It's a POV. It's a user. Our brain kind of has a user interface with what we call space-time, and it's not that space-time is totally illusory. It's important, it's consequential, and it's a form of reality, but it's only representational, and it's a map. So it has the limitations of any map. It cannot show you the full, territory.
Yeah, how some people say that, well, the world gets created because we perceive it. And I think, well, wait a minute. Let's say there's a tree. Now, a cow, a bat, a snake, a human, a dog, all these beings could be perceiving the very same tree. And obviously they perceive it each very differently, but there's something there, that doesn't depend upon their perceiving it to exist.
Right. That's anti-realism, and the fallacy in that. Now, somebody can be anti-realist if they want, but it's an option. It's not forced upon us. And the way I think a good way to see this is in terms of the allegory of the blind men and the elephant. And many times this is kind of what's driving the anti-realist narrative, is the idea that each of the blind men has a different theory about what they're dealing with, and they erroneously conclude from that there's no elephant, but I'm sorry, there's actually an elephant there. It's just that the nature of the elephant is such that it cannot fit into any particular map, that corresponding to the abilities of each of those blind men. So it doesn't mean just because we, in order to develop a theory about something, we need to perceive it, and our perceptions and our knowledge and our conceptual toolbox is perhaps limited. That it doesn't follow that there's no elephant there. Right. So that's the mistake. That it's certainly there. The elephant doesn't need any of the blind men. It doesn't need any of their theories. It's perfectly
sometimes fine. I think, like, with regard to this argument, I think, okay, does the moon exist because there are people around the world perceiving it? All right, well, what if everybody in the world suddenly went blind for some reason? Would the moon disappear? Oh, but you could still go to the ocean and stick your toes and feel the tide coming in. I mean, are your toes creating the moon because you feel the tide coming in?
Yeah.
That's absurd.
Now, the reason we got into that kind of silliness is because the standard theory cannot explain what a measurement is. It cannot explain the transformation of quantum possibilities into actualities. And again, that's where the transactional formulation helps, because it says, okay, look, fields are behaving in a different way. They're actually mutually responding. There's a response that's crucial. The yin element of field activity is crucial. And when you have that theory of fields, then the phenomenon of the moon is always there. It's like the elephant. The moon is always there. And the standard theory, to kind of use this elephant metaphor, cannot explain, why anyone ever can see a moon. It can't really account for that. So it just, we have to have an observer. That's what we have to have, an observer, and then we'll be able to get a result. We'll be able to say that the moon exists. But again, that's also to kind of conflate existence with the tip of the iceberg level, and so it's just this idea that that Bohr fell into also. It's because the standard theory could not tell you what is it at the quantum level that gives a specific result at the space-time level corresponding to there's a moon there. So, I mean, that's probably kind of glossing over some technical things. But
we got to gloss if we got too technical.
Okay.
Here.
Yeah.
But are you alluding to, like, Heisenberg's uncertainty principle with a two-slit experiment, where it becomes a particle or once it's observed, which a lot of spiritual people interpret to mean that the world becomes concrete because we're observing it. And I'm not sure that they're correct in making that assumption.
Kind of, yes. I mean, I guess the better analogy here is the Schrodinger cat experiment.
Right.
That the standard theory, that's actually an anomaly for the standard theory, because it's got this deterministic Yang-only character that you get these superpositions at the quantum level. And if you don't have any specific process that tells you where your superposition ended, why you got, one or the other, then the superposition propagates endlessly out to the macroscopic level, and it's absurd. And then someone has to kind of go, okay, when a conscious observer comes along and opens the box, then that they collapse the quantum state. So that's just a Band-Aid. And, the prevailing, or, resorting to the idea of a conscious observer is kind of a Band-Aid, and it doesn't work, because then you get this infinite regress of like, well, what counts as a conscious observer, and
how did we get a universe to begin with when it was probably billions of years before there could actually be sentient life,
Right, exactly. So that this is the measurement problem. And so the measurement problem is sort of arriving at spirituality and consciousness through the measurement problem, I would say, is not the right way to get an implication from quantum theory, because that's like the defective form of the theory. And in fact, you can, and I've written about and published papers on how the transactional picture very specifically and quantitatively tells you how a so-called measurement happens, the symmetry breaking, the crystallization, the transformation of possibility to actuality really happens in the proper formulation of the theory. So the hand wave to consciousness, it doesn't really work anyway, because you can't define what counts as a conscious system, right? You can't, and you just get, it gets, you get into inconsistencies and flagrant failure if you do that. So I think that the legitimate parallel is, again, to this idea that that there are these sort of two levels of reality. One is the more phenomenal level, and the other is the subtle level of possibilities.
Yeah. Now let's break that down a little bit. And we do have another question from Elizabeth that I'm going to ask, but it seems to me that it's not either or. It's more like a spectrum where there are subtler and subtler and subtler levels, which, at least in terms of the consciousness model, I'm not sure how that would translate into physics. And then there's an unmanifest level, which is beyond the subtlest. It's said in spiritual circles that in these subtle realms, we have astral and celestial phenomena, ghosts or celestial beings, or, stuff that you can't see with the ordinary surface level of perception. And then there's the whole idea of, I don't know if this relates, I might be jumping here, but there's a whole idea of dark matter and dark energy, which comprises most of the universe, which physics doesn't understand what that is. So, I wonder if there's some corollary between the fact that most our perception is just on the very surface of life most of the time, for most people, and there's so much more that we don't perceive. And in terms of the universe itself, we can only perceive a small fraction of what we know exists, because we can't perceive in dark matter or dark energy. We can only infer their existence from certain mathematical calculations.
Well, as far as the sort of from the TM tradition, I remember the
bubble diagram.
Sort of the bubble diagram. There we go. And I guess I would have to say that physical theory probably deals only with the very upper part of that bubble diagram. Like I would sort of take quantum theory as probably, and again, I'm kind of not sure about this, but my sense is that's a more manifest form of reality already, so that I don't think that physical theory is even getting at these what one might call the astral level, or these much more subtler levels. So there may be this subtle gradation that you talked about, but once you get to the kind of systems described by quantum theory, there's a lot more structure there, even though they're possibilities, they're not space-time objects. And at that point, what we have, at least what the theory seems to say, the transactional formulation seems to say, is that these are well-defined possibilities that exist like the elephant exists, okay? They cannot all be phenomenally experienced by the five senses. But there's a specific process that transforms some of them into, like, again, to use the game analogy, into something you might see in your POV. I just ran into that tree. Okay, well, a particular possibility in the game program just got actualized for you. So that's really what we're dealing with here. I should say, as far as dark matter and dark energy, I've actually written, I have a publication with a colleague of mine where we argue that the positing of these substances, dark matter and dark energy, are actually ad hoc devices that are based on weaknesses in the standard theory, the non-transactional standard cosmological theory that cannot explain, certain things like galaxy rotation rates. And actually, if you take into account this actualization process that happens in TI, you actually get a formulation of general relativity where you don't need to posit dark matter and dark energy. You get the phenomena that you see. It predicts these rotation curves that are deviating from the standard theory. So I just kind of need to point out there that, the orthodox position is, dark matter and dark energy exist, but that's just a theory, and it's just kind of, those are ad hoc substances that are put out there because of anomalies in the standard theory. So
very interesting.
Yeah.
Wow. In my next life, I want to be a physicist. Okay, let's get Elizabeth's second question in here, and then we'll go on to other things. So her question is, how does non-locality coexist with Newtonian causal mechanisms? Is it related somehow to what we might consider miraculous events? Amit Goswami refers to two levels of causation: upward causation, which aligns with materialist assumptions and moves from atoms to molecules to cells, and downward causation, in which consciousness is seen as foundational. I'm not sure if that's two questions or one.
Let's see. Well, non-locality really applies to that part of reality that's the submerged portion of the iceberg. So when you have in the possibilities, in the realm of possibilities, they are not limited by space-time, because once again, that realm of possibilities is like the user playing the game in their house. They can put the game on pause. They can go get a cup of coffee and, come back and then start interacting again as their avatar and do things that show up in the POV. So that's kind of how non-locality plays in. It's, they could say,
give us an example of non-locality. Isn't that the thing where you could have something, two particles on the other opposite sides of the galaxy, and explain that?
So there's no actual space-time distance in quantum land, what I call quantum land. So you can have sets of what we call particles. They're not localized necessarily, so I don't like to call them particles, but just quantum systems that are correlated, that are in a particular collective state, such that whatever sort of measurement is done on one of them has consequences as far as what's the kinds of probabilities of outcomes you're going to get on its partner. And so you can have an experiment where you send these guys off to, opposite ends of the galaxy, and one experimentalist measures one of them and the other one measures the other one, and they find these correlations that can't be explained in the usual local manner of what she called the Newtonian manner. So no, Newtonian physics cannot explain that. It cannot explain that at all, because it deals with, it does not allow for, really this level of possibility in which you have connections ongoing that seem to violate relativity theory that governs space-time phenomena, but they don't really, because they're going on in the submerged portion. Only the tip of the iceberg, metaphorically speaking, is subject to relativity.
Okay, so you're saying that the tip of the iceberg is limited by, let's say, the speed of light. And so there's no way that particles on the other side, opposite sides of the galaxies are going to respond to one another in anything under 100,000 years time. But that there's a unmanifest or submerged reality, which is not constrained by the laws of physics that operate on more superficial levels, such as the speed of light.
Right. And in fact, I mean, these quantum systems, I mean, the subtle point here is that these quantum systems are always in the submerged portion. Anything that has rest mass never actually comes out of this portion. What happens is you have specific interactions that give rise to events. The events are in the tip of the iceberg. So once again, it's like, your cup of coffee remains in your house and your hands manipulating your mouse while you play your game. They never are actually in the game. They're not in the game environment. That's sort of the parallel here. So what we call space-time is kind of the structured set of happenings that happen in your user interface only. They're not happening in your house. There's nothing in your house corresponding to you running into a tree. There are phenomena that's the only thing that's in space-time. Events. So there are events, but events are not the systems themselves. So
right.
It's an unusual. We're not used to making it. We usually think, oh yeah, everything's in a space-time container. But actually, no, nothing's really in a space-time container. Phenomena, events, phenomenal events, and they need not be seen by any particular entity, but they are still events. They are.
So they are events, but they are beyond space-time. They don't. That's the only thing space-time is. And again, ironically, what we call space-time has neither space nor time in it. It's just a set of events connected by light, by photons. It's like a bunch of Tinker toys, if you will, connected by light. And it's just a map. I mean, some people could say, well, maybe it doesn't really exist in a sense. One could interpret it that way. I mean, I think of it as, there's a structured set of events, and that is what space-time is. That's the only invariant thing about the space-time manifold. And Einstein said that himself. I mean, he said, space-time is what he called point coincidences. That's all I mean when I say event. And the terms space and time refer to our kind of maps that we bring with us. They're like reference frames that we bring with us. Like if I'm in my house, I'm like, I got my watch. Okay. So in a sense, there's kind of a form of time that applies at the quantum level, and that corresponds to what we call proper time in relativity. But technically, I know I'm kind of throwing a lot at you. It's all in my books here. And what I'm talking about right now is discussed in Chapter 8 of my second edition, 2022, of my Cambridge University Press book. Chapter 8 discusses this, that the ironic thing is that what we call space-time, it's not a container. Stuff doesn't exist in it. It's a set of events. That's the only thing that's invariant about space-time. So it's like it's almost not there. Just like your user interface, everyone's very, their attention is on it. Like all the players are like, oh my God, look, I got to get that scarab beetle. I got to do this. I got to do that. And they're really into it. They're like, but actually, no, none of your objects really exist there. Right. So, which is reminiscent of the way some supposedly enlightened people have described their experience. The world is just this ephemeral sheen, of faint remains of ignorance on the surface of a vast, totality of consciousness. In fact, in Vedanta, they sometimes use the analogy that, when you're totally ensconced in the world and not enlightened, it's like you have a big wad of butter in your hands, and then eventually you get enlightened and you throw off the butter, but there's still a greasy surface on your palms because you were holding the butter, and that's called lesha vidya, which is said to mean faint remains of ignorance, which is said to be necessary, if you're going to live in the world. You have to sort of take the world somewhat seriously, or you'd be
it's consequential.
Buses
right. And, obviously it's more painful to go wrong in our reality than in a game,
Yeah.
But it's a good analogy. I mean, like if you think of enlightenment, and I don't know that this is, I'm not enlightened much as I'd like to be. I've had a rough year and I'm dealing with a lot of challenges, and anyway, but my particular user interface has really been a pain in the neck lately. And I'm really in there. I'm like, oh no, now this happened. Oh my God, what do I, but it's those events are consequential if you're playing the game. And now maybe we have a reason to play the game. Maybe we need to be involved in this particular game. And, but again, that's if you kind of notice, oh, wait a second, I can put this game on pause and, get a cup of coffee or whatever, that it's not the totality of reality.
Yeah. I think that when we put the game on pause and go get a cup of coffee is when we die, and then come back in your body. Yeah, meditate too, which is in a way death because you transcend individuality.
Yeah.
So you studied philosophy of science, which I find very interesting. I took a course in which we studied Thomas Kuhn's book for a month. The structure of scientific revolutions and, paradigm shifts and all that. And you said at one point in your book that the assumption that space-time encompasses all of reality is the stumbling block to the acceptance of the new scientific revolution or new paradigm, just as the experience that the sun and everything else orbits the Earth was the stumbling block to the acceptance of the heliocentric model of astronomy. So a lot of people feel that the world is a mess because we have a fundamentally upside down understanding of reality. In fact, there's a guy I interviewed named Mark Gober who wrote a book called The End to Upside Down Thinking. And he basically presented all the arguments in favor of consciousness being fundamental and everything else being more, epiphenomenon of consciousness rather than consciousness being an epiphenomenon of the brain. And I think you can extrapolate from this upside down thinking to understand why the world has so many problems. We view the world as inert material stuff. We view bodies or people as being these transitory things. And once the body dies, that's the end of it. You don't exist anymore. We don't sort of see the intelligence that's shimmering in every little particle of creation. We think we can do anything to the environment as if it were just dead matter and not a living reality and so on and so forth. And so that's the world we structure. Whoever dies with the most toys wins. And I think that a consciousness first philosophy, or God first, if you want to put it that way, if you want to think of pure consciousness as being divine intelligence, if that were our orientation or perspective, we would structure all of our political, economic, business, environmental, agricultural, et cetera, systems completely differently.
Mm-hmm. Yeah. Well, clearly, as you've laid out, our Western materialist worldview has dire social consequences, and in particular, the Cartesian dead matter paradigm, and Democritan atoms in the void just clunking around, and that obviously there's no meaning in that. Obviously, if you want to have any sort of meaning in a metaphysical picture like that, you got to kind of be ad hoc about it, because your ontology doesn't support meaning. So yes, I definitely agree with that. And I think the other kind of toxic element of that dead matter picture is, again, this yang only, along with the dead matter goes this yang only idea where the only thing that's real, the only thing that counts, the only thing that's seen, and the only thing that's significant is the tennis serve, the unilateral, metaphorically speaking, tennis serve, that one entity can unilaterally put stuff out there and do stuff in this autonomous way. And that's why we have the measurement problem in the standard theory that still isn't fixed, because that's part of the one of the core beliefs. if you have a picture of field interaction that involves yin, that sees yin, that makes yin, that allows yin to be in there, and it can be very easily be in there in the mathematics. And that's actually the most general, natural approach to field theory. It's actually eliminated in an ad hoc way, by Richard Feynman was one of the ones who did this. Great, brilliant guy. But what he did was he said, we're going to take these fields. I don't like this non-local, character, but he initially started with this great theory that would have worked, that is actually transactionally the basis of the transactional picture, and that was the Wheeler-Feynman absorber theory. But then he decided he didn't want to work with that anymore. And then he got into this standard approach where he says, we're going to impose causality, and got at his causality hammer, and he said, okay, my field theory is now going to be causal because that's what I see in my user interface here. I see people it's going to be causal. Darn it. And in a very ad hoc way, he created what's called the Feynman propagator that is now canon in field theory. And this is yang. It's pure yang. It's like, okay, I'm just going to, in an ad hoc way, take out my causality stamp and say, this is the way fields work. And then now you have the measurement problem, and, you have stuff that doesn't work. So what actually, the most, before Feynman and, people who thought that was a good idea and went along with him. And there's something about it that makes sense, but the ad hoc nature of it doesn't. But people thought, okay, well, we need to, have this kind of propagator because we want causality. That's what we want. That, nature's like, wait a minute, what about me? And they're like, well, we don't care about nature. We want what we want. And this is, but if you look at the math, the most general solution is a non-local one in which charged particles are non-locally in communication all the time. And it's not causal in the yang sense, in that autonomous yang. Bucket brigade, I call it sort of a bucket brigade. It's not causal. But if you allow for that, and that allows this yin component to enter, where fields are actively kind of responding to one another, and you can quantify that probabilistically. And if you allow for that, then you get this, you get an account of the transformation from, your behind the scenes game stuff I'm doing as a user to, I got an outcome. I see an outcome. I can see why I got an outcome. I can quantify it. Whereas the standard theory can't do that. And so this is the pathology here, is wanting to not have yin, wanting to pretend as though reception, listening, responding, and annihilating, which is all, those are all yin processes. The standard theory wants those to not be there. If we allow them to be there, then we get all kinds of great solutions to our problems, and that's also kind of remedying this, conqueror mentality, because what you just laid out with your question was this dead matter destructiveness. Whoever dies with the most toys wins. And part of that is not seeing the other. Part of that is, what do I want? I'm all that matters. I'm autonomous. I can do whatever I need to do without anybody's help. Nobody needs to respond to me. I don't have to listen to anyone. So see, all this whole pathology, and along with this goes misogyny, the sort of female, like, I hate playing the woman card, but I think Betty Kovacs in her books, Merchants of Light and so on, has made a good case for, a lot of the pathology being the denial of yin.
Yeah.
Okay, we don't have to be receptive. I don't have to listen to anyone. I'm being very yang now, kind of, but I don't. It's just like yin doesn't exist, and now with what we see happening, it's kind of the Kali Yuga, if you will, and Kali is kind of the ultimate yin warrior. She's like, well, guys, you tried to pretend like yin didn't exist. Well, she's coming for you.
Interesting. I've interviewed Betty Kovacs. I love that interview, and it was very popular. She got a lot of views.
I think she's right on target with that. That it's a pathological neglect of. It's like a fear of yin, because yin has this sort of, the night, the darkness, and it's scary, maybe.
Yeah, and it might seem unusual to people to suggest that these sort of deep philosophical considerations could have such real world consequences as, our wars and economic upheaval and wealth disparity and all these different things. But that's exactly what we're suggesting, that, all these surface problems are symptomatic of deep underlying mind states.
It's a dysfunction.
Really.
Yeah, it's a dysfunction. And I mean, it's a lot, I'm sure there are problems all over the world and Eastern cultures too. But, personally, what I see when I go out is kind of, the manifestation of the neglect of yin. I see, parents out with their children, and the children, they're out in the marketplace and they're in the user interface at shopping or whatever, and the children are calling to their parents, and the parents are in yang mode. I want that. I'm going to do this. I'm going to get this, and they have no yin. They don't hear their child calling, needing their attention. They're not receptive. Because we don't have to be receptive. That's what our culture tells us. We don't have to listen. We don't have to receive. And, and that creates a lot of, subtle trauma and. Yeah. So that's, I'm on my little soapbox now. But.
That's okay. And you mentioned Eastern cultures. I mean, anybody who's been to the East, spent some time there, realizes perhaps that although some very beautiful philosophies were born in those cultures, the actuality of what's going on doesn't necessarily reflect that wisdom. It's either been lost, or it's never been applied, or it's not being applied now, or whatever.
Sure. Yes.
Yeah.
But I think in those cultures, they at least have some kind of ability to do things like wait and be passive. And it's not so taboo. In Western culture, it's sort of more taboo to be passive or to be viewed as passive. So the yin is taken as weak passivity, and that's kind of a distortion. That many times yin behavior, is seen as weak. And I think that Eastern cultures generally don't kind of have that handicap that Western cultures do.
Yeah, I mean,
they may have their own dysfunctions.
What may seem like passivity might actually be an appreciation of the intelligence that orchestrates the universe, and how things are not just arbitrary and random and accidental, but there's a wisdom in the way things unfold, and you want to flow with that rather than just sort of, butt your head against it.
Of course. Right.
Yeah.
Yeah.
Let's talk about free will and determinism a little bit. You did a nice critique of Sam Harris's book in one of your books, and you used the term that I always use when I refer to this topic, which is wiggle room, and that is that we don't have absolute free will. I mean, I can't play basketball like LeBron James if my life depended upon it, and but then on the other hand, we don't have zero free will. We're somewhere in between with a certain amount of wiggle room. And in my opinion, the way we use that wiggle room moves us towards either greater freedom or greater bondage.
Yeah. I definitely think that there is, I would not say, oh, I know we have free will. Like, I wouldn't be dogmatic about it. I don't know for sure that we have free will. But what I argue is that the usual arguments that claim that we do not have free will are just not tenable. And so I mean, that's what I do with my, discussion of Harris's comments. And I mean, what's unfortunate is that authority figures, people, neuroscientists and physicists and so on, make these categorical statements. They make these claims that, claims such as physical theory tells us we don't have free will. And that's a false statement. It's just simply your whoever's saying that, Professor X's metaphysical assumptions, together with his interpretation of a physical theory, result in a conclusion of no free will. And what Professor X doesn't know is that so many of his assumptions are completely optional and almost certainly wrong. So it's just a real, I think, irresponsible kind of a form of, this may be strong language, form of professional malpractice on the part of scientists to say things like that. Physical theory tells you don't have free will, because it's just, it's a abuse of authority in a sense.
Yeah. It could be that people who ascribe to that attitude or that perspective have a vested interest because they don't want to believe in the existence of a jiva or a soul or something that's independent of the body. I was listening for quite a while to Sean Carroll's podcast. I think he's a physicist, and I remember hearing one episode where he was having a debate with B. Alan Wallace, who's a Buddhist teacher. And in fact, I remember I was out shoveling snow while I was listening to this, and Sean Carroll made some kind of a statement like, just adamant with that. When you die, that's it. Lights out. There's nothing after. It wasn't even like, this is my belief or my theory, or I don't see any evidence for an afterlife. It was just like, boom, that's the fact. And B. Alan Wallace is like, what can I say to this? I mean, I think you're going to be pleasantly surprised when you die.
Yeah, it's
interesting how unscientific scientists can be.
It's
even
so dogmatic, and it's against the spirit of science to be dogmatic in that way. I mean, the fact is that scientific theory has nothing whatsoever to say about anything that goes beyond, what can at least be indirectly empirically corroborated. And where empirical is, now here's where I go to the flatland analogy. I think this might help us here. The flatland story by Edwin Abbott, where we have a bunch of geometric figures whose whole reality is a flat plane, a two-dimensional surface, and their sensory organs are on their periphery. And the idea that there could be three dimensions is just hogwash to them because they can't sense it. Okay, and their theories that they've devised seem to work well to corroborate their perceptions and predict things on their flatland plane. Well, then one day this sphere comes in, decides to have some fun with flatland, and he does things that are viewed as very mysterious and non-local, right? And can't be accounted for by the usual flatland theories. And in a way, that's really what quantum theory has kind of been doing, that if we interpret it in a realist way, that quantum theory is referring to, metaphorically speaking, spaceland, to another part of reality that, no, we can't poke it. No, I'm sorry, but indirectly, we can manipulate things that obey this, that seem to behave according to this theory. So, I mean, what Sean Carroll is basically doing, so if at least one can admit that there is an aspect of reality that it doesn't fit into what you think of as your space-time container, meaning your flatland, realm of perception, then we don't know what else might be out there in other areas of reality that we can't, directly empirically corroborate. And now suppose we have your Buddhist teacher debating. Okay, yeah. Who's debating Sean Carroll? Who it's a woman? You said
no, he's a man.
He's a man. Okay. So suppose Wallace. Okay, suppose Wallace has had a spiritual experience. Well, we could model that. This is just hypothetical, as say a sphere coming down, and have Wallace's body be in flatland, perhaps a part of his body, maybe be in flatland, and have the sphere coming down and touching him in his interior, then going back out. Will no one else? Sean Carroll is out there. He's a square. He's out there in flatland. He didn't see anything. He can't do any experiment that can corroborate that happened. But if our vision encompassed that, then empirically for us, we could say, yeah, we saw this, I don't know, spirit dragon, whoever, this divine, whatever it was, come down and touch Wallace and go back out again, and they can have a little laugh about it. And Wallace had an authentic experience internal geometrically internal experience. And who is Sean Carroll to say, no, that never happened?
Yeah.
He can't say that. He has nothing to say about it.
Just to elaborate on the Flatland thing a little bit. So Mr. Flatland is sitting in his living room, right? And a sphere comes into his living room, and all he sees is a circle because he's in two-dimensional world. But he can't see anything that has three dimensions like a sphere. So he's like, oh, look at this interesting circle. So he's kind of picking up on something is happening to his living room, but he doesn't have the tools, the perceptual tools or understanding to comprehend or perceive a sphere. And so it's a good analogy because there could be stuff all around us, angels and all kinds of things that are just outside the realm of our perception. And there might be indications in our world that they're there, but we ignore or misinterpret those indications because we can't perceive them.
Right. We can't directly. They're not empirically available to us. And those kinds of events, and I don't know whether angels exist or not. No angels ever contacted me, but the point is, if someone has an experience, okay, so suppose someone reports, this little episode that I just concocted where a real sphere came down and just touched a flatland shape in the stomach, went back out again, so that only that one individual had that experience in an internal way. Well, it was not an empirical event at the level of flatland, so no one else can say, okay, that conforms to my scientific theory. But they also can't say, like Sean Carroll, that didn't happen. He's overstepping his authority. He's speaking from ignorance. No, it's possible.
I mean, he's a brilliant guy. I like listening to his podcast, but still,
he's got metaphysical presuppositions that he takes as correct and not optional, and he doesn't know what they are.
Right. So he's not being scientific.
Right. Exactly. I mean, this is where philosophy is so important to science because, and physicists often kind of like to bash philosophers, but the fact is that as I said elsewhere, physics was originally called natural philosophy, and you don't do physics without the discipline of philosophy in some form, critical thinking, being aware of what your premises are, not dogmatically stating conclusions without taking into account what auxiliary hypotheses and assumptions went into arriving at that conclusion. And so if you do stuff like that, you are not being scientific. Like you can't say, if suppose we have the statement, if it is raining, then the grass is wet. Okay, there's a theory. Fine. Okay, now I go out and I see the grass is wet. Well, you can't say, okay, I know it's raining. No, you can't. I'm sorry that somebody might have had a water sprinkler on that's affirming the consequent. You cannot do logical fallacies and claim that you're doing science. And a lot of the time that's what we're getting. We're getting just, these kinds of careless, dogmatic statements.
Right. And, and then of course there's the whole political situation in academia where it's getting more open now, but there were times where you couldn't barely mention the word consciousness without jeopardizing your career. So all of that is very unscientific. I mean, that kind of attitude. There's that. You've probably heard. Have you ever spoken to the Galileo Commission or the Scientific and Medical Network?
Oh, Scientific and Medical Network. Yes.
Yeah,
yes.
David
Bernard
Lorimer
Carr.
And Bernard Carr.
Yes. I know them well. Yeah. I met Bernard in Paris at the Paris Center.
They'd love to have you speak to one of their webinars. A few questions have come in and try to tie it down to earth for those of us who don't understand all this too well. This one is from Hamza Al-Rashdan. He didn't say where he's from, but here's the question. What do you think is the role of the observer and observation in breaking out of the history and trajectory of an energy in the quantum field?
Well, again, the term observer is kind of ill-defined as it's been used in physics. And again, it sort of came in as a Band-Aid to fix the measurement problem. So because the standard theory couldn't tell you, well, what kind of interaction counts as a measurement, meaning what kind of interaction counts as something that can give an outcome. And so there was an appeal to an outside observer. And this is actually, I've argued problematic and not necessary. So in a sense, that kind of, use of the term observer is sort of neither necessary nor sufficient to do what people wanted it to do, was to try to say, okay, why is Schrodinger's cat not in a superposition, right? So in a sense, rather than kind of observer, we need to sort of come to grips with what kind of process is it that crystallizes an event, that brings about an event. And this is a very subtle issue, and it gets into sort of technical issues. But again, the involvement of yin is critical. So these are processes. Now, we call them quantum fields, and this might make someone wonder, well, what happened to consciousness? What happened to, the idea that we don't want to be physicalist and well, we don't have to assume dead matter in order to have these processes go on. So these processes are going on, and they're dynamical, but there's a key element of yin. There's kind of a give and take and a mutuality among fields. And again, the theory itself can only say, here are the conditions, things like energy conservation, conservation laws must be satisfied, and I have to have the right kinds of systems whose properties are compatible, and so on. In those conditions, all you get is a probability that at any particular time, some kind of energy flow will happen, which means you get a real quantity of energy, a photon, going from one system to another. So it's kind of like a handshake, kind of like a manifestation occurs. But this is only governed by a probability. It's fundamentally indeterministic. So this is where there's room, like Rick said earlier, about wiggle room. This is sort of where we have room for volition. And, this might address the questioner's, intent a little bit, that perhaps this is where volition can enter and arguably might even need to enter, that at some level nature kind of says, okay, I want something to happen. We're gonna transfer this energy now. So there's a symmetry breaking, and that could really call for volition.
Yeah. You quoted Freeman Dyson in your book as having posited that elementary particles like photons and electrons might actually have some rudimentary form of volition.
Exactly. Right. And, I don't know that, but it's an interesting kind of, and I have a paper on that that's fairly technical, but it's, many times people will say, well, you can't have volition, or you can't really have free will, because then you'd be a slave to the quantum probabilities, even though there's indeterminism. But that isn't really true, because the kinds of choices that, complex organisms make are really not described by quantum states in any kind of one-to-one fashion. But anyway, that's a technical point. But indeed, we can say, well, okay, these atoms, decided, okay, now's the time that I'm going to hand a hunk of energy to you. Now those at the level of the atoms, they are constrained by the probability law, but that doesn't mean that there's no volition. And in fact, if you kind of think about the idea of the principle of sufficient reason, that if you have a number of possibilities, but no reason to pick one or the other, that nothing's going to happen. So then the only possible reason could be volition. So, under that kind of analysis, then you need volition for anything to happen at all.
Okay, interesting. Here's a question from Lydia John in London. Could Ruth say a bit more about what is meant by the transactional formulation?
Yeah, so the transactional formulation it's based on this so-called direct action theory of fields, or the absorber theory of fields, that was developed in the early 20th century by a number of people, notably Richard Feynman and John Wheeler, although there were others that developed it, that were exploring it before them. And it basically involves, I mean, this is where we get a little bit technical, and I want to kind of do it on a conceptual level. But it involves the idea that a charged particle, that by a charged particle, we just mean a particle that is a possible source of the electromagnetic field that underlies light. So that these charged particles are constantly connected to one another in this direct action theory by what's called a time symmetric field. So this is very non-local connection. This is where we get the kind of yin component coming in. It's not this causal autonomous yang picture. It's a very mutual, mutual kind of relationship. It's very relational in a way, again, that Western metaphysics doesn't like. So there's like an instantaneous relationality among all charges. So that's one feature of it. Another feature is that, like I was mentioning before, under certain circumstances, systems can elevate that basic relationality to what can be seen as a process of individuation, where one of them, where they are jointly emitting, where there's kind of a response. So you have one system that has the potential to give off some energy, and another system that has the potential to take up, to accept that energy. That's the yin component. And that this absorbing particle actively responds by generating another field that's time symmetric. And the fields interact in such a way that they kind of reinforce each other in a wave-like way, so that energy goes from the emitting quantity to the absorbing quantity. And this ends up like a causal space-time process. So this is the emergence. And it comes out of this transactional process, and you don't get that. In the standard theory of fields, there you just have it models it as follows: an emitter gives off a photon, that's it. So there's no mutuality, there's no handshake, if you will. It's just assumed to be autonomous. So that's on a very conceptual level. That's kind of how I can relate, what the essence is. And I think my book, Understanding Our Unseen Reality, kind of has kind of a diagrammatic explanation of that process.
Okay, thank you. Here's a question from Mila Now in California. Can you please explain the basic significance of the delayed choice quantum eraser experiment? And do the outcomes of this experiment support your interpretation of quantum mechanics?
Well, I have a paper on that experiment, and it's entitled "The Delayed Choice Quantum Eraser Neither Erases Nor Delays." So unfortunately, that's a really fun experiment that mainly highlights the non-locality in quantum theory, but unfortunately, nothing is really erased, and it's unfortunately, been kind of portrayed misleadingly. And I don't know if I, can get into enough technical detail here, but it's basically, under the transactional picture, you get a clearer account of why you get certain outcomes. It's two correlated particles, and one of them can do an interference effect or not, or collectively you get a bunch of hits, and collectively they will either form an interference pattern or not. And another particle is sort of that particle's partner, and they're correlated. And the transactional picture helps you understand why you get outcomes. But it's really standard quantum theory explains why you get what looks like erasure if you're not taking into account certain things. So it's that's kind of the best I could do for now. Is I can definitely provide my paper, but it's not erasing anything. Nothing's being erased. There's nothing that's going back in time and erasing anything.
Okay.
It's a kind of a misuse of statistics to make that claim. The claim that things are being erased is to overlook certain things with the statistics. So, yeah.
Let's say that Jesus actually walked on water, and Saint Joseph of Cupertino and Saint Teresa of Avila and many yogis in India actually flew in the air, and all these different cities that we hear about from just about every ancient culture in the world. Let's say those things really happened and theoretically could happen in this day and age. Do you have any idea what the physics underlying that would have to be?
Not really according to the standard theory. I mean, I could say in terms of our game metaphor, you could say, well, the game has a certain program that tells you what kind of zones there are, what the features of the zones are, how the avatars interact in those zones, how likely they are to sink into water when they fall into it. And those are the rules of the game. They're written into the software. And so I can kind of speculate that a hacker, somebody who is really good at the software, could go in and say, well, my avatar, I can hack these. I can put in a little subroutine here and I can hack that and just change just the way the software works. And my avatar can do that. So it's like from that metaphorical picture, it's kind of simple to see a consistent way to create those phenomena. Now, however, the standard theory, it seems like they'd probably have to hack the rules, something about the probabilities for the standard theory. So, I'm not sure how that would work. But, clearly you can't, you don't want to rule it out from the idea that the phenomenal realm is a statistically highly likely result of a lot of possibilities being factored in. And if someone is at a level where they have access to and can perceive the source of these possibilities, in the analogy being hacking the software, well, sure, why not? I'm not sure whether the rest of us would see, oh my God, you just violated quantum theory. That I'm not sure.
Well, tell me what you think of this argument. If consciousness is utterly fundamental, if it is equivalent to the unified field as physics conceptualizes that, and then in my understanding, the unified field would contain in some latent or seed form all the laws of nature, which eventually manifest and perform their functions. Well, if they're equivalent, then consciousness contains all the laws of nature, whatever they may be. And in terms of consciousness, we might understand them more as impulses of intelligence rather than as inanimate laws. But in any case, if there is this equivalence and one sort of masters the field of consciousness, as it were, knows oneself to be that and learns to function within that, then would it not be possible perhaps for that person to have as Jesus said when he calmed the waters, out on the boat when they were in danger. He said, one of the apostles remarked, even the winds and sea obey him, because you can say he had mastery over the laws of nature. And he did that not because he was the Son of God, but because he was one with God, and God contains all the laws of nature. And, if you can function from that level, you can do all sorts of things that you can't if you're just off on some little end of the spoke of the wheel.
Yeah, sure. And again, in our analogy, that would be like changing the software. The Matrix, right? Like changing the Matrix. We all know Neo when he was like, okay, I see the code. I see the code. I could see the bullet. I don't need to have that bullet there. So yeah, I mean, why not? There's nothing that kind of rules it out. I mean, the question is then, would you, I guess a hard-headed physicist would be like, okay, would I then have empirical violations of the quantum probability law? Well, would you? I don't know. I mean, it'd be fun to test that, and if you do, then you can say, okay, fine. Then as you said, what we call these laws are just sort of regularities that happen to apply at this sort of collective level. That doesn't necessarily mean they're immutable. I mean,
Yeah.
quantum theory is multiply confirmed. It's a very, very well confirmed theory, and it's never been seen to be violated.
Right.
That doesn't mean it's inviolable.
Well,
Right.
I don't even think we have to consider violating it. Like airplanes and birds might appear to violate the law of gravity, but actually they're just utilizing other laws which enable them to kind of to fly through the air. So it could be that yogis and people like that have mastered laws of nature which don't violate the known laws of nature. They're just using laws of nature that we don't commonly know yet.
That could be.
Yeah.
Yeah, that could be.
Okay. So we covered non-locality. We've covered the observer effect, I think, and tell me if we haven't. But then the holographic principle, that's a theory that states that all the information about a three-dimensional object can be encoded on a two-dimensional surface. And some spiritual people interpret this theory to mean that the entire universe is a hologram and that we're all interconnected in some fundamental way, which I believe we are. But I don't know if that means that the universe is a hologram. But do you think there's any correlation between the holographic principle as a purely mathematical theory and our real world experience?
Well, interestingly, my co-author and I use the holographic principle in our paper on deriving a generalized form of general relativity, and but we use it in a way that what's sort of contained in this inner environment is possibilities, and so the mapping isn't maybe the way it's usually thought of in terms of a holograph. It's more information about the possibilities can be kind of represented on the surface, but then we get we do get a transformation that's physically significant. It's not just an appearance thing. It's not illusory. It's a real transformation from the form of possibility to the form of actuality. So I guess in the picture that I'm kind of comfortable with, or the way I've used it, it wouldn't really be legit to say, well, the universe is a hologram, because I think that would take out a crucial aspect of the dynamical process where we really do have possibilities being transformed into actualities at the level of empirical experience, things that can be empirically corroborated. So that's kind of it's the mechanism by which by which we get a tip of the iceberg. So it has significance, and the tip of the iceberg is not a replacement for the submerged portion. They're not the same. They're both there, but they have different character, if you will.
Okay, good. Actually, I'm glad you mentioned that tip of the iceberg analogy before, because when we were just talking about siddhis or supernatural powers or abilities, most people in the world are the tips of the iceberg, but a being, a yogi, a saint who could do those kinds of things that we've been discussing would be someone who kind of like knew the whole iceberg, who was aware of the whole iceberg, and who was familiar with all the laws of nature that superficially we interact with, all the more fundamental laws, and who could therefore, it's like, okay, this sort of, I was going to bring up this analogy when we were discussing free will, but it kind of relates to this also. If you wanted to change the course of a river, let's say, if you're down at the mouth of the river where it enters the Bay of Bengal or whatever, you really can't do much. The whole river has run its course, and so you're at the mercy of whatever it floats down. Probably corpses and things, if it's the Ganges. But if you're up in Gangotri, where the river starts, then according to the topography, you might be able to send the river off in a completely different direction because because the whole river is downstream from you. And so it's kind of like that.
Much more powerful at the source.
Yeah, it's like that with thoughts. It's like that with just our actions. If we're functioning from a causal or fundamental level, then we have tremendous leeway or leverage that we won't have if we're just stuck at the surface at the mercy of whatever bubbles up.
Yeah, I think I love that. And I think, as a so-called law of nature, quantum theory, I think, is really operating very close to the surface. It's very near the mouth of the Ganges, so to speak.
Huh.
It's got a lot of statistical force behind it. Because it is so well corroborated. But again, I think it's not the tip, but it's very close to it. That's the way I see the analogy here, because it's such a strong regularity.
Yeah, but would it be fair to say that it deals with the world of the very small, but not necessarily the world of the very subtle? Would that be fair?
Yeah. Yeah, I mean, okay. Yeah, and I'm not quite sure how physically I would define subtle, but again, it does have very specific structure.
Yeah.
So it's close to the level. Here's where Kabbalah might come in. My daughter happens to be very interested in Kabbalah, and she's always, telling me about the tree of life, and there are like all these different levels of manifestation. And it could be that quantum theory is it sort of one of the spheres that's just very close to the concrete Malkuth Sephirot, so to speak. So,
yeah.
But I don't know much about that.
By subtle, I would mean, like we were talking before, astral and celestial and so on, where there could be angels or, celestial beings and other things like that, which you wouldn't see with a telescope or a microscope or any gross instrument, because they exist on a dimension which the gross can't necessarily tune into, and which gives us this is an interesting idea. Could we think of the human nervous system as a scientific instrument, which, let me step back a bit. I gave a talk once at one of the Science and Non-Duality conferences about the sort of a mutually enriching potential relationship between science and spirituality. And, I think spirituality can benefit from science in that it can become more rigorous and empirical and, and less imaginative and fanciful. You really sort of want to know what's what. You don't want to go off on imaginal tangents. But on the other hand, science can benefit from spirituality in that the human nervous system is an investigative instrument, if you will, which possesses capabilities that no other man-made instrument has in terms of its ability to experience consciousness and also to experience all the subtle realms that exist between the gross world and the transcendent or unmanifest world. And I guess the question would be, could the human nervous system be used in a systematic way so that everybody's subjective experience could be correlated or corroborated in a way, and not just be, subjective experiences that could very well be imaginary, and there's no way of determining it.
Well, I think I think there are people who are trying to do that. Ed and Emily Kelly are people who come to mind. That they are, interested in the paranormal, and they are endeavoring to be very scientific. And
see the guy at the University of Virginia,
Ed Kelly. I met him at Esalen. And his wife Emily, I'm not sure.
Could be. He works with Jim Tucker, and who does reincarnation stuff. There's 3 or 4 people down there who investigate these.
Could be. It could be. I'm actually not sure about his affiliation, but and I think that's so important. But again, it's like I see physical theory, physical science is properly restricted to the empirical realm. And that's kind of both its power and limitation. And even if we have, to use our flatland analogy, a bunch of squares meditating and contacting spheres, and they're all like, yes, okay, I got poked, this guy, and it still is not going to be an empirical corroboration, because it's not going to correspond to the tip of the iceberg. So right. It's tricky. I mean, what it means is that, physics is very powerful by being able to predict stuff that happens at the tip of the iceberg, but it needs to be more humble when dealing with what's viewed as anecdotal reports. It can't just say, well, you said this happened to you, and he said this happened to him, and so on. But how do I replicate that in the lab? And so that's, instead of being arrogant and smug about that, they need to say, okay, that constitutes a domain of inquiry that physics is not qualified to address, period.
Yeah.
That's my take on it. They need to stop being, it's just, there's a constraint on physical science. It's the empirical constraint. It's an advantage and it's a disadvantage. And it can't be used like a bludgeon to say, look, you didn't give me a procedure by which I can corroborate your subjective experience in my lab. Therefore, go away. You're stupid. And that's what a lot of physicists want to do. And that's what they shouldn't be doing.
Empirical means it can be experienced, right?
No, it means third-party corroboration.
Okay.
It means it's got to be really fully manifest. And that's the tricky part. See, so the analogy is in Flatland, even though, suppose everyone in the room said, gee, I felt something, you felt something, I felt something. But if it's the spheres call the shots, and if they are operating according to some law that the Flatland domain doesn't know about, then there's sort of no way that it's sort of not initiated by those experiencers, and they can't say to some other square comes in who maybe wasn't participating, okay, guys, well, tell me what's your theory and how should I, and they can't.
Right.
They can't say, okay, well, stand here, we'll put up a laser that, it wasn't up to them.
Right.
No, maybe if they could gain access and say, okay, do this, eat this food, eat this mushroom, do a prayer to the West, then you'll feel what we felt. Maybe. Yeah. But, that's not really third party empirical at the stage.
But maybe it could be, but not quite as concretely as science is accustomed to. But let's say the yogi or the Zen master or whoever is sitting there with a couple dozen disciples, and he says, okay, here's what I'm experiencing, and you are not. But we're going to embark on a 10 to 20 year scientific experiment here in which I am going to lead you systematically to be able to experience the same thing I am experiencing. And then we'll have, a couple dozen of you who have empirically corroborated my experience.
So he would be flying or something
or whatever,
like that.
Even just experiencing enlightenment, experiencing pure consciousness as its true nature.
Physical theory would be like, okay, I'm glad you're happy. I just don't think physical theory, if there wasn't some phenomenon, this is physical science is about phenomena.
Right.
Empirical physical science is about phenomena. If there's no phenomenon that can be third-party corroborated, then it has nothing to say about it. And it doesn't mean that it didn't happen at all. It simply means it's outside the domain of physical science. Now, that doesn't mean we can't be scientific about it. We can be rigorous. We could be, the term scientific means more broadly than just physical science. We can be responsible psychologists. We can be responsible sociologists. We can be quantitative and document, people's experiences, but it wouldn't enter the domain of physical science because it just,
well, it's tricky.
It is tricky. And but it cuts both ways. I mean, that's why physical scientists do not have the authority. They do not have the standing to say, you didn't have that experience and what you're saying is wrong. And it didn't happen. They don't have the standing to say that.
I mean, the folks at the Large Hadron Collider say they've found the Higgs boson, and I believe them. I have no idea what the Higgs boson is, and I would. Well,
that's also interpretation. Again, they have phenomena. Okay, so they have some data. That's the key. Do you have phenomenal data that everyone can look at? Okay, well, we've got some data now. By a bunch of auxiliary inferences, we conclude that we saw the Higgs boson.
Yeah.
Well, I don't know. I'm not going to dispute the data. They've got third-party data, but then what are the conclusions are?
but the vast majority of humanity has to sort of take their word for it and say, well, if they say there is, they found it, then maybe they found it. I don't know what it is. So like that, I'm suggesting that, the materialist scientists, if we flip the tables on them, would have to admit, if they were honest and open, that all these saints and yogis and spiritual people throughout the ages who say they've been experiencing this, that, and the other thing, and there's a lot of commonality between what they all describe, might actually be onto something that is, very as real as anything we study, but beyond our methods for studying things.
Right. Yeah, I agree. They can't just dismiss it. I mean, it's experiences that don't result in third-party data of the kind you get, with the colliders and so on.
Right.
There's no third-party corroborated data. However, there's a preponderance of experiences, and that is a kind of data, but it's not physical theory data, but it's in a broader scientific sense. They can't just dismiss it. In other words, they can't dismiss it on the basis of, oh, you didn't give me any empirical data in the kind that, they can't say, therefore, what you're saying is not a valid claim, because that's outside the domain of it. They can just say, well, I don't believe you, but they can't invoke physical science as a reason to refute what you're saying.
Yeah. Let's take the example of dreams. Most people dream, and they know they dream. I mean, everybody dreams. Most people remember their dreams a little bit, at least when they wake up. And we know that there are certain neurophysiological correlates to dreams, rapid eye movement, certain brain waves, and so on. So, it's a universal enough phenomenon that everybody accepts it, even though it's an entirely subjective thing. I've never experienced your dreams. There's no way I could. What did Bob Dylan say? He said, I'll let you be in my dream if I can be in yours. But anyway, so like that, let's say that enlightenment was nearly as common as dreams are, and there were certain neurophysiological correlates to enlightenment, which I believe there are, certain brain waves and other measures, then it could be part of the zeitgeist, and it could be part of the mainstream in human endeavor for gaining knowledge, and respected just as much as a physical scientist's findings are respected, and on the basis of which we can build bridges or send rockets to the moon and so on.
Yeah, I mean, it's definitely part of a scientific inquiry, and can be. And again, I guess the point here is that physics is really a very limited kind of science. It's very powerful, but also very tightly constrained in terms of what it can count as data and so on. Right. So it's kind of in this tight little box, but as a specialty science. But definitely, you can be scientific about these kinds of experiences, and yeah, I mean, I totally agree with that.
Yeah. But it sounds like what physics does, or many physicists anyway, not all, is they're saying, well, if it doesn't fit into our box, it can't really exist.
And that's a metaphysical choice to say that if something doesn't yield third-party corroborated data, then it is not real.
Right. Which is presumptuous.
That's not a science. No, you didn't derive that from any scientific finding. You just decided to think it.
Yeah.
Right.
Yeah.
So it's an optional premise that they want to shove on other people, which is, again, a problem.
Yeah. Okay. I did a pretty good job on that one. So moving on. Let's see here. So let me just throw a few of these things out and see if you feel like commenting on them. There's string theory, which some people who don't understand string theory use to argue that everything is interconnected. Want to comment on that at all? Should I move on to another one?
Well, I mean, I think string theory is one of those theories that was kind of explored to try to come up with solutions for problems that aren't problems in the transactional picture. Yeah. So I'm not sure we even need it. It's sort of one of these things that was explored to kind of try to surmount certain anomalies and weaknesses in standard cosmology, and so and it's highly speculative, and so I don't really, beyond that, I don't have a whole lot to say.
And I should add that I think everything is interconnected, just from my own, spiritual explorations. But what I don't want to do is use an example from physics, which actually doesn't support my belief. I'd rather say, I can't think of an example. There are no examples or something. But
quantum theory already does. I mean, it already does do that at the submerged level, with, especially in this direct action picture of fields, then literally, certain kinds of systems, and maybe all systems, depending on their properties, are mutual, have a relationality that's intrinsic to them. And there's no definable distance or separation. There's no definable identity, in a sense. So already, quantum theory already supports that picture.
Earlier on, you were using the game metaphor to suggest that we're like an interface that, it's almost like the graphical user interface of a computer. Also, there aren't actually little files on my desktop and all that stuff. It's all just zeros and ones, but we have an interface that we can interact with. And, some people say that they might reference Einstein's idea of time dilation to support this idea that time is really malleable, and that in fact everything is simultaneous. I've heard a number of people say that all of our multiple past lives aren't actually past; they're simultaneous, but that we impose a linearity on the world and have this concept of time in order to function in this human reality that we find ourselves in.
Well, I would say that in the transactional picture, especially in the relativistic form, we have the only sense in which there is a flow of time, a concrete flow of time, is at the tip of the iceberg. So that's where there is, and it's a process that happens. But again, it's sort of at the level of the user interface, and at the submerged level, at the level of behind the scenes of the users themselves. There's a kind of a form of time, but it's more of a potential time. It's more of a vibration. It's like a pulse. It's actually the de Broglie wave, the so-called, you can look it up, but it's a quantum aspect to matter. It's the wave nature of matter. And it's more of a pulse that it doesn't have a temporal direction. It's just a pulse that is the potential to define a temporal separation between possible events. So that's kind of where we are in the behind the scenes, quantum land submerged portion of the iceberg. So in that sense, it's a kind of an eternal now. But it does have this pulse that is the potential to manifest as a transaction and as, if you will, the rope turning into a snake, Yeah. But it's like this then to mix metaphors here a bit. It's the skin of the snake, so the real snake is in there, and it's changing. Things can change in quantum land. Things can happen. It's a dynamical. But there's a point where the skin is shed. Those are like the events that are realized. Something's really happening. Okay, something happened. There's, a piece of skin went off, as if you will. There's like a record of a particular stage of the snake's existence, if you will. But that's not the snake. It's a phenomenon that the snake gave rise to. So I don't know if that kind of addresses the temporal.
So are you saying that that time as we experience it is just a kind of a concept that we can function within, whereas in the ultimate reality of things, what time actually is does really not resemble at all what we experience. Like, for instance, I've heard
at the phenomenal level,
Yeah, from the perspective of a photon, I've heard that there is really no time. It gets
That's correct.
from here to the Andromeda, here to the Andromeda galaxy instantly.
That's right. Yeah. That's right. Eckhart Tolle talks about now, the power of now. Well, in my picture, that's because systems are always in the now. So we're in the now, and we experience a flow of time in that we with our senses and so on, we experience events falling away from us. Events are actualized and they fall away from us. So we experience change. We experience change, but we are not the change. It's the phenomena that are changing.
Right.
So that, and I think that's all consistent with quantum theory. It's just that the standard, approach doesn't want to go that direction because they want everything to be Newtonian yang only. And they also want to live in a space-time container, so.
Okay. So, there's a guy, Nassim Haramein, and others who talk about 0-point energy, and we could power the whole society if we could come up with 0-point energy devices and so on, and maybe the space aliens already have them or might give them to us and that kind of thing. What do you think about all that?
Well, 0-point energy is actually an artifact of standard quantum field theory. And in the transactional formulation, you don't have 0-point energy. you have force. Force is not the same as energy. So, this is a technical issue, but because of the way quantum field theory was developed, it's the bucket brigade local causal approach, and it has to posit certain systems that I think aren't really there. And it's just, and these systems seem to have energy, but you don't need those. It's like a mechanical tinker toy apparatus that's created to keep everything local. In the transactional picture fields, you don't need any of that. And you actually get all this correct predictions, and you don't have 0-point energy, which is actually a problem and an anomaly for the standard theory because, why can't we measure this? And, it's kind of embarrassing. But still, there can be a lot of force. So there's definitely something happening that's analogous to the 0-point energy. And there's this continual interaction, this relationality, this direct interaction, but it's force. So energy is technically force transferred over a distance or force acting over a distance. But in the direct action picture, there's force acting, but it's not acting over a distance. So it was like infinite force. So make of that what you will. Maybe it's powerful in some way.
So speaking of space aliens, do you think, and with your understanding of the sort of unmanifest realm and quantum objects within the unmanifest realm, can you conceive of the possibility of some technology which would enable, beings to create some kind of interdimensional means of travel, or to cross hundreds of light years almost instantly, or anything like that? You think there could be a physics to those sort of technologies that a society a million years more advanced than ours may have mastered?
Well, technically, there are certain theorems that would seem to suggest that you can't exploit the quantum realm in that way, in that you can't, there are definitely these non-local connections, but they can't be exploited to transmit energy. Now, there are theorems to that effect. Any theorem has assumptions, Now, if some of those assumptions turn out to not hold, then maybe it would be possible. That's sort of from my limited, as a person, not very, I'm not good at imagining technology. So I'm not sure how much more I can offer. In principle, under quantum theory, it seems to suggest you can't, but again, it's sort of like, well, they said you couldn't fly, and we could. So I would never rule it out personally. There may be aspects we haven't thought of. And again, there may be these deeper laws that we don't even know about.
Yeah.
Yeah.
There was a conference down in Mexico some years ago. It was moderated by Dan Harris of ABC News, and Sam Harris was there. And he was debating Deepak Chopra and Gene Houston. And it was
I saw some of that.
Did you see that?
Yeah, I saw some of that.
And Deepak was spouting his, physics ideas and so on. And there was a guy in the audience named Leonard Mlodinow.
I remember that.
remember, who challenged Deepak, and they ended up becoming friends and writing a book together called "The War of the Worldviews." And I have a few summary points from that book that I want to bounce off you. There's 5 chapters in the book, and they each focus on a different topic. One is the cosmos, in which Deepak argues that the universe is a conscious being, while Mlodinow argues that the universe is a product of chance and necessity. What are your thoughts on that?
I don't feel qualified to weigh in on that. I mean, I mean, that's really nice that they're kind of collaborating in that way and having this diversity of views. I mean, my sense is that volition is a fundamental part of reality. That we can't pretend like volition isn't in there, and so that I think my own opinion, reality is fundamentally creative, and creativity involves volition. And in my opinion, if you don't have that, then things are kind of meaningless, and we are just kind of dominoes, a row of dominoes falling down. So I'd like to think there's intent and volition and creativity at the deepest levels.
Yeah, actually, Irene just passed me a note, which is that if we don't wrap it up now, the dogs aren't going to get a walk, and we've been going for 2 hours.
We can't have that, and I might get kicked out of this room very soon. And you might get kicked out of your room. So, like as P.T. Barnum said, we'll leave them wanting more. Okay.
And take these things up another time. But it's been delightful talking to you. Very stimulating conversation, and it kind of makes me a little bit smarter by osmosis to talk to somebody like you.
Well, thank you. It's always fun. Great questions from you and the listeners, and really appreciate the opportunity. So enjoy your dog walk.
Yes, thank you so much, Ruth, and thanks to those who've been listening or watching. And my next interview will be with a fellow named Jem Bendell, who has written a book called Breaking Together, which I won't go into the details right now, but stay tuned. I think you might find it interesting. So anyway, thanks, Ruth.
Okay, take care. Thank you again.
You're welcome.
So long.
Bye-bye.